Okay, class, welcome to part 2 of the 1.1D video lesson, and we will now be just solving word problems. The directions for solving word problems are always the same. Obviously, you want to read the problem, you want to create an equation, you also want to define some things depending on the word problem, and then you want to answer your equation. You want to answer the question that they're asking for in a complete sentence. Okay? So let's start with a very basic question. Number 7 says the length of a certain rectangle is 4 meters greater than 5 times its width. Find the dimensions of the rectangle if its perimeter is 20 meters. Okay, so whenever we compare two things, right now we're comparing the length to the width. This second noun, the noun after the comparison, is always labeled x. Right? This is true for every comparison. Whenever you compare something to something else, that second comparison, or the second noun, the noun after the comparison, is always and should always be labeled as x. Right? Watch how this works. Since the width is after the comparison, we immediately should write width is x. Then, once we have the width defined as x, we should then say that the length is 4 meters greater, which is 4 plus, or plus 4 at the end, 5 times the width. So I'm going to go ahead and define length as 5x plus 4. Now that wasn't too bad, was it? All we did was just read the first sentence and we already have two expressions. It says find the dimensions if the rectangle has a perimeter of 20 meters. So let's remind ourselves that the perimeter of any rectangle is going to be 2 times whatever the length is plus the width, right? It's length plus width plus length plus width. So there's really, you just take the length and width and you can double the sum of that, right? If you would like a visual, remember that perimeter is the outer edge of a rectangle, and really there are 2 L's and there are 2 W's. So all you have to do is just add the length and the width and double it. And in this case, the perimeter is 20, so I'm going to go ahead and be able to go like this. I know that the width is x and the length is 5x plus 4, and I can just plug that into my L and W and set that equal to 20. Does everyone see what I did here? I know that the width is x and the length is 5x plus 4. So now I've created the width and the length combined, which is this group right here. And instead of distributing to the 2, I'm going to go ahead and divide both sides by 2. This actually makes my values a little bit smaller, and I end up getting, now let's go ahead and combine like terms. X plus 5x is 6x plus 4, and that's going to equal 10. Okay, so now I could just subtract 4, right? When you get to this point, the two-step equation part, it should be pretty simple, pretty obvious that x is just 1. And once you have x equals 1, you now want to plug it back into your definitions and really calculate the value for each dimension, right? The width is 1, and if you plug in 1 for the length, 1 for x, I should say, 5 times 1 is 5, and the length is therefore 9. Now, that should make sense because the width plus the length should have a sum of 10. Because if I double it, that will give me a perimeter of 20. So I've kind of mentally double checked, and I realized that yes, this works. Now, obviously, my picture is not drawn to scale anymore because you could realize that the length has to be 9 and the width has to be 1. But That's okay. And you would say the width is 1 meter and the length is 9 meters. And you're done. Maybe even box your answer just to make it look solid. Okay, so really you just have to be comfortable realizing and kind of figuring out which one of the two is considered x. I think this is the secret. Once you see the word then, you kind of know, okay, that's the comparison word, and this noun with is going to be my variable. Okay, so let's use this strategy on other word problems. Okay, so let's go to number 9. It says the measure of the first angle of a triangle is 10 degrees more than, here's that word than again, the measure of the second angle. Okay, so the measure of the first angle is 10 degrees more than the measure of the second angle. The measure of the third angle is 30 degrees less than the measure of the first angle. So this can be kind of confusing because now you're comparing. Yeah, there are comparison words, but wait a minute. Which one should I label x? Find the measures of each angle. So I know that the second sentence is comparing the third to the first, but let's not even look at the second sentence and let's just define our variables with the first sentence. The measure of the first angle is 10 degrees more than the measure of the second angle. So this is interesting because now we should, therefore we should label the second angle as x. So I'm going to do that. I'm going to label the second angle as x, and I'm going to say the measure of the first angle is 10 degrees more. So that means the first angle is just x plus 10, right? 10 degrees more. After we've defined this, right, then we can talk about the second sentence. You don't want to work reverse, or you don't want to say, oh, you just look at the second sentence, because then things will get a little bit trickier if you do that, believe me. The measure of the third angle is 30 degrees less than twice the measure of the first angle. So this is intense because the third angle is 30 degrees less, which is minus 30, than twice the measurement of the first angle. So you have to take this first angle and double it. So it's a group and you're doubling it. So let's go ahead and write the third angle. You take the first angle, you double it. Notice how I doubled it by using a group. And then you have to take 30 degrees less than that. So that was tough. I admit that was a little bit tough. So you might want to put a star next to this third angle and make sure that you understand exactly where we got this. But 30 degrees less than twice the measure of the first angle. So I doubled the first angle, and this is an expression, so you have to put it in groups. And then I took 30 degrees less than that. Okay, so I'm also going to go ahead and simplify this because it might be easier if I simplified it. So this is 2x plus 20 minus 30, which essentially is 2x minus 10. Okay. Now, these angles are being described as a part of what shape again? Actually, I don't think it's. Oh, yeah, it does say. I almost forgot. It's a triangle, right? So we know that the sum of a triangle has to be 180 degrees, right? A sum of a triangle is 180 degrees. So here comes the fun part. It's time for us to create the equation. So x plus 10, which is the first angle, plus x, which is the second angle. Oops, I wrote equal, but I'm going to go ahead and make that a plus. Plus 2x minus 10, which I've simplified from all this to be the third angle. And this is going to equal 180, right? Because it's a triangle. All three have to add up to a triangle. So I know that x plus 2x, I'm underlining the like terms, that's 4x. Then I have 10 with negative 10, and what do you know? It's gone. 10 and negative 10 delete themselves, and this is going to equal 180. So the calculation of this is really not that bad. 180 divided by 4 is 45. So I know that the first, not the first angle, the second angle is 45. The first angle is therefore 55 because it's plus 10. And then the last angle really has to be, well, process of elimination. You kind of add these two and you know that it has to be 80, right? Also, if I were to double x, which x is 45, that's 90 minus 10, so that's 80. So I know I'm right. And now you'll have to write the final concluding part of your answer, which is the three angles are 45 degrees, 55 degrees, and 80 degrees. Okay? Solid. Hope you enjoyed this video, and obviously there are more problems to practice with. We'll do some more in class. Thanks for watching.